Uh, Hello, everyone. Um, uh, Thank you for giving me the opportunity to present our research in this prestigious conference. My name is Saifuddin Saif, and in my research, we have other two authors, Janal Rashid Mehuddin, Dr. Janal Rashid Mehuddin, and Dr. Kevin from Colorado State University, USA. I myself from Chicago State University from United States. Today, I'm happy to present our research, augmented reality integrated vision model, robust vision model for sign language recognition. Shortly, we call that as SLR, or sign language recognition, using computer vision and machine learning. So in this research, we integrated AR, which is a part of mixed reality technology, and uh, and also we integrated computer vision in this research with machine learning. So computer vision is to interpret the scene, that is computer vision. I mean, whatever we see using our eyes as a human, how robots or machine can see the same thing using the human perception model, that is computer vision. And because eyes are related with the human brain, so learning is involved there. So how human learns, that if we want to copy, we are saying that is machine learning in machine learning perspectives. So human learning, we are referring here as a machine learning. That means how human will learn. Same thing, how we can copy that to the machine. That will interpret as a machine learning. And we use a mobile device as in the form of augmented reality to integrate the processing using machine learning and computer vision to augmented reality. So that's why we saying that we integrated augmented reality. So so computer vision is the main part here, and we all know that augmented reality is a part of computer vision. So then it becomes easy for us to integrate augmented reality with computer vision. And the learning thing, we use machine learning. More specifically, we used faster RCNN machine learning framework in this research to predict sign language recognition using a hybrid method. So let me proceed forward to explain more details about our research. So because human subject involved here, and for the machine we are interpreting computer. So human computer interaction is there, and we applied HCI in that context to sign language recognition. The intention here to enhance the communication between the people who understand who understand sign language and who do not understand sign language. So our research uh, facilitates the communication between the people who understand sign language and who do not understand sign language. Okay, so that's the introduction in easy word. And we use several semantic codes, semantic characterization we use in this research, which normally used in all other research relates to sign language recognition. One is hand gesture we used, and embodied learning also we used here. So that is body orientation and movement. And we use facial expression also because in sign language, the facial expression is important to understand sign by the machine. And eye gaze recognition, mouth shapes identification, those are involved as a semantic tools in our research. So current research problem. So good for me to explain why we are doing this research. Basically, all the researchers in this research are from computer vision. For example, myself is from computer vision and augmented reality, virtual reality, image processing domain. Professor, so Dr. Jainal is from machine vision and augmented reality, and Dr. Kevin, Professor Dr. Kevin, he is from language department. Language, I mean, Professor Kevin is from language background. So, who helped us a lot in this research. Towards perfection. So, previously in sign language recognition, we know that artificial intelligence is very, advancing day by day very rapidly. So, uh, nowadays, artificial intelligence, the concept is very, very wide. And if we talk about artificial intelligence, there are many subdomains involved here, such as like computer vision, image processing, augmented reality, and virtual reality. And when he saw that, or when he explored the sign language recognition problem, we saw that there are a lot of advancement happens. In terms with machine interpretation for sign language recognition. But we surprisingly noticed that the augmented reality, virtual reality, computer vision, those domains were not explored adequately for machine interpretation, which can help the society, the community, to remove the barriers in terms of the communication gap. So the people who use sign language recognition, it's hard for to communicate for them to other people who do not understand sign language. So, for example, if the work in an office, and it becomes very difficult for example, people with disability in terms of the communication, to communicate with other people in the office, or even in the school, or any other workplace. So if we can develop a mobile application that can recognize, that can interpret that what is the people with sign language user, with disability, with special people, how they're saying, it becomes easy for the co-workers, for example, in a workplace, to communicate with them, and that will increase the productivity. And this application can 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 help those people with the people, with the special people, to mix with the normal people in the society, can make their life easier, and we can treat them like we as the normal people are. So this application can provide that, can remove that communication gap with those people and the normal people, and make their life easier. So we try to use this computer vision, machine learning, or deep learning, and augmented reality for sign language recognition, to improve to remove the communication gap for those people. And then there are a lot of advancement happens in computer vision, augmented reality, and virtual reality. Some issues such as like hand actions, facial embedded landing challenges, and those problems are a fatal problem in computer vision too. So because we are from computer vision, augmented reality, and virtual reality domain, and we for the next of our life, we want to investigate those issues too. And we surprisingly noticed that those embedded challenges are also exist in sign language recognition. So at the same time, we can do something for the society or the community. At the same time, we can carry out our research problem that towards solution. So those things also we want to investigate. So that is another reason, that other problems that motivate us to this research. Okay, so yeah, that's the motivation for doing this research. Okay, good to know some existing methods which are used before to address sign language recognition. This I mean based on my so far explanation, such as like previously people use machine learning, some methods from computer vision, but very little method, very few method actually found relates to augmented reality. So based on our knowledge, I think we are the first people who are trying to address the language using augmented reality. However, from computer vision side, or machine learning side, there are many methods, not to say many methods, but a good number of methods available who addressed sign language recognition. For example, the deep BiLSTM, normally LSTM used to summarize the video. So previously, some researchers, they use deep BiLSTM. Then, from computer vision perspective, cascaded classifier for efficient classification. That when this one used from the deep learning, and then artificial neural network was used, SBM was used, super vector machine. Then convolutional neural network was used. Shift was a very known methods for which can absorb motion, can provide motion information very using rich feature descriptor. And then previously researcher use a Markov random model, very famous model for motion modeling. There are some people they use virtual reality. Then a local binary pattern also some people use for classification. Principal component analysis people used for which help mostly in dimensionality reduction thing. And then people also use LDA for efficient classification. And also relates to shift, another method was used, which is mean shift segmentation. So those methods used previously for sign language recognition in the context of machine interpretation. However, computational complexity, then, like I mentioned before, the semantic cues, we try to use semantic cues, which is hand gesture recognition. So hand gesture recognition is a particular problem where same color hand, the color constraints exist there. This means that when same color hands, or the color-based recognition for hand gesture recognition, or color feature-based feature extraction becomes an issue for most of the methods. So we based on the problems for all those existing methods, we came out with the hybrid method using existing method, and then combining that with the machine learning methods, and then we use augmented reality to process the fusion. Okay. So good to see our proposed method. Yeah. So good for me to explain our proposed method after that. Okay, so this is our proposed method. Our proposed methods mainly involved with four steps. One is data pre-processing, then RGB, MHI attention module, and first IRCMST, and then is the final fusion addition that we have that I have been, that's our main goal in the proposed method. So in the data processing, we perform the processing using median filtering, then cropping things happen, and then we resize the images and so on. So those are the basic parts for the data processing. Any research you do in computer vision, that is a very common thing. And then we propose RGB MHI attention module. So In this module, actually, our main intention is to grab the motion information, then other semantic cues such as like the facial expression, eye gaze recognition, then our forehead explanation, finger identification, those things. And one thing in this module we focused that that in this module we did not focus on a specific region extraction. For example, let's say any sign language, if that involves hand recognition. In that case, we did not focus on the hand only because some in sign language actually there are a lot of signs that involves hands or face, but most of the sign language are involved with a combination of multiple organs. If we use hands, then our facial expression also involved to fulfill the meaning of a specific sign language. Okay, so in this module, we focused to summarize the overall scenario. So, for example, if the camera is focusing on me, it's not focusing on my the summarization of the output of this module. It's not only the face or the hand. It will summarize the overall scenario you can see based on the human subject. Okay, so this module gives the summarization of flat feature map to provide as input to the machine learning framework. Okay, and then after that we use faster RCNN. We know that faster RCNN is a very efficient machine learning framework. It provides high accuracy, and then it provides the feature extraction it performs. It directly performs in the neural network module, not separately not separate other classification layer as needed in this case. So anyway, I mean, faster RCNN is very efficient, and it overrides other machine learning framework in many contexts, such as like its ability to handle a wide range of objective scales, aspect ratios, and it integrate the region proposal, which is ROI, we say region of interest, directly into the neural network, making it faster and more efficient comparing with other neural network. So that's the reason we use faster RCNN, and finally we fused RGB MHI module and faster RCNN. Okay, so those are the 4 steps. As a summarization, we used data preprocessing, RGB module, MHI module, and then faster RCNN and fusionization of machine learning and RGB MHI module. So this is a overall framework for the fusionization. So in the RGB, we have common components such as like RGB, red, green, blue, and other features we integrated in the MHI module, such as like symmetric cues, textures, edge, colors, etc. And some other basic things in the classification layer. We use classification layers, and then for the benchmark deep learning framework, we use BDD16 for the feature abstraction. Okay, for the overall classification, after we provide the information from the RGB MHI module as a flattened feature maps, fed into the first arsenal, and after that, in the final classification layer, the prediction thing happen for the sign language recognition. So anyway, with this overall picture, this overall fusion module, we can see the we mentioned in our paper, and more details we mentioned in the paper. And also, I'm happy to answer any questions if after our presentations or even by email if we have. Hopefully, the overall methodology should be interesting for all of us. So anyway, this is the proposed methodology, and the fission module, in this figure, like I mentioned. So we use components like RGB, and then other features such as textures, edges, and colors. Then we fed those information in the first arsenal, and then in the final classification layer, the prediction thing happened for the sign language recognition. We use several data sets for the experimentation. So the first data set is AUTSL data set, and good to mention that all the data set we used in this research, the data for all the data sets is above 20,000 video frames. So a lot of data we use for the validation, and for almost all the data set we got the best result comparing with other results. Okay. So anyway, finally, here I mentioned in this table regarding the accuracy, regarding our expected results, accuracy and competition time. After fine tuning, we got the final results as a 98.97%, and competition time was 12 seconds. And if we compare these results with the previous research, for example, BT and PF proposed by D. Costa DTL, then attention-based by LSTM. So for comparing with all the data sets, I mean, our results is far more better, 98.97%. But other results comparing with the previous results on AUTSL data set, we got the best result. So I think in all contexts for this dataset, the AUTSL dataset, we got the best results, and this made us confident about our proposed method. Actually, there are many reasons that we got good results in our proposed method. For example, like the proposed RGB MHA module, was formed from the feature map received from the base network, which I mentioned that BGG16 that we used, that the base network, to extract semantic informations using various features such as like texture, color, or corner features, and then later we fused with faster arsenal for final classification. And then for strong semantic cues, such as I said, texture, edges, or color features, faster arsenal, this deep learning framework help us to locate the region of interest in fewer selection windows comparing with other feature extraction network. And that also better aspect ratio comparing with other deep learning network, which influenced significantly to identify the classified objects and improve the accuracy comparing with the previous research results. Okay, so anyway. Then the next data set we used in our research, which is Bosphorusing 22K. boasts for a sing for a sin 22K. I'm sorry for the pronunciation challenge for this dataset, but anyway, this dataset also contains more than 20,000 video samples, and we got the best results also in this data sets, which is almost like 97%. Um, Although we got some higher competition time because this is a fusion model we used in this research, so that's the reason. But otherwise, in terms of the accuracy, we got the best results in this data set also. So that's the comparison with the previous research results. We can see we are the topmost in this data set also, almost 97%. But other researchers comparing with other research methods, um, below than us in terms of the accuracy. Okay, we also develop a new data set in this research. That's the Amar Bhasha. This data set name we gave the name, and we got the results. We estimated the results or the accuracy based on different the character in the language called Bangla, and most of the cases our results is almost like 100%, and computation time also quite impressive. We also use other methods in this data set, and we found that our proposed method in our new data set also provides us the best classification results, which is very encouraging for us for our future investigation. Okay, so I mentioned all the results in our we mentioned all the results in our research paper, and like you see, I mean, we applied neural network ensemble, then SBM, then artificial neural network in our this method, sorry, this data set, and most of the cases, I mean our proposed methods got the best results. Um, uh, uh, so that is very motivating for us. Okay, this is some sort of qualitative results for the presentation. So I use some of the sign language we used in let's say, used in sign as a sign for communication. So our results are very promising. In the Amar Bhasha, especially Amar Bhasha data set, which is newly developed. Okay, so in conclusion, I would mention that our deep and hearing impaired community will be benefited hugely in the United States and Malaysia and Asian countries. And the good thing is our current research is is we're planning uh, for a lot of extension in the upcoming futures. And we believe that this research will help the deaf and hearing impaired community to mix with the normal for the normal activities with the normal people in the society or community. So this will significantly will enhance the lifestyle of the deaf and hearing impaired community in USA, Malaysia, and other Asian countries as well. And our future research involves we plan to investigate in more diverse data set. The domain adaptation is a big issue in sign language recognition. So currently we use only 3 data set, but we plan to apply our method in various data set depending on the countries or cultures. We know that sign language recognitions I mean it varies from country to country, depending on the language. So we plan to apply our method in various data sets and then improve our method accordingly based on the challenges that we may face in our upcoming times. Yeah, so that's we plan in future. So that's all for my presentation for our research, and you can find. We'll be very happy if you have any question. You can email me. You can email anyone, any researcher, any authors mentioned in this paper, and for any questions, and we'll be happy to answer your questions anytime. So please feel free to contact us for any question and on any question anytime from now or later. We'll be happy to answer. Thank you.